Hi everyone. In this video, I will do my best to answer a typical question that many of you may have heard before, and it is about what happens behind the scene when you click a link or visit a website. Technically, both are the same. And again, to answer this question, you have to see who is your audience, for who you are going to try to elaborate or answer this question. Depends on the background or whatever your audience is expecting to hear from you. You may come up with different versions of your answer. Okay, so that's the key. And we have to remember this as the first point. Okay, so one of the best references in the internet that everybody can refer to, it is a book written by Jim Cruz and Keith Ross, and the book name is Computer Networking: A Top-Down Approach. It is a very popular book. You can see it reached to its eighth edition, and the authors of the book published already many useful material for the teachers, for the students, including the slides, the exercises, many supportive material that whoever is willing to use this book as a textbook, they can use that. And in the slides that have already been shared by the author, in one of the slides they have already gone walk through answering this question. What happens when, let's say, you are going to visit a website, and what steps usually your request have to take to reach to the destination. And you can see that it can be a rabbit hole. It depends again to what extent we are going to see what really happens behind the scene, very simplified version or very complex version. Okay, and I'm just trying to go something in between. I can show you how can be easy explained or how it can be too complicated. Depends on who are you trying to elaborate or delineate this answer. So yeah, this is a very simplified version. As you can see here, I borrowed this from byte go website, and you can see somebody enters a URL in the browser. The URL can be break it down to domain, path, and resources. Your browser just at the first step usually tries to find what is the respective IP address to the website that you are going to visit and sends your request to the DNS or domain name system. DNS itself, we can talk about DNS for hours. It is a very complex system. It is the phone book of the internet. It converts your domain or a website to an unique identifier. We call it a public IP address or an IP address. Your browser has a cache, DNS cache, and checks, okay, this website has already been visited or not. If it is visited, it is going to just grab the IP address from the cache, and we are good to go. Otherwise, he has to go and ask another DNS server. We call it the DNS resolver. And this DNS resolver, if it doesn't have in its cache, then this guy need to do through a process we call it the DNS name resolution, which is going to ask some DNS servers that we call them root name servers. We have 13 root name servers. We call them by alphabets from A, B, C, D until M, 13 letters. And these are not 13 physical servers. These are 13 clusters of the servers. And by asking them and going through a recursive process, finally you find out, oh, okay, for example, the IP address of www.google.com is this IP address. When you have that number, now we go through another process, which is, okay, establishing a connection, a TCP connection. And or Transport Control Protocol, it is another protocol which guarantees the reliable delivery of your request over the internet. In the internet, we have millions of routers, switches that your request pass through them, right? And then more than 50 years ago, a gentleman called Windsurf, many people, we call them the father of internet, he come up with transmission control protocol more than 50 years ago, and it's still more or less the same. And this is going to be used to guarantee your request will be delivered reliably to the destination, to google.com, right? So we have a procedure, we call it three-way handshake. This three-way handshake will be done through the TCP, and then on top of that, we have HTTP, or the web, the protocol that indeed you visit the websites in your browser. And there is a secure version of that. We call it HTTPS. This is a very simplified version, and you can say this is how you visit a website on your phone. So here you can see this is the extended version of the TCP handshake, seen SYNAC ACK, more details. The DNS, the name resolution procedure that I mentioned here, you can see we have a root name server, the 13s that I just mentioned, top level domain, authoritative name server, and finally you get the IP address of the the website that is not in your browser, the cache of your browser. And then the HTTP request will be sent. The website content is JavaScript, HTML, CSS will be fed, will be rendered in your browser, and you see the content. Okay, that's another version of that with a little bit more details. Or we can go a little bit beyond this. What happens when I turn on my Wi-Fi radio on my phone and connects, for example, to Wi-Fi network in the university, in the campus? What happens from then? When I turn on my Wi-Fi, I connect to a Wi-Fi network. Then I am able to access to a website such as google.com. Yeah, we can consider that also as some extra steps that happen. So in this case, usually your computer, your laptop, your phone need to send the request that we call it the DHCP discovery request. So the DHCP discovery request, it is a protocol that gives your computer first an IP address. Without having an IP address, which is again a unique identifier, your phone, your laptop, your computer is not able to communicate or send and receive requests over the internet. So that's the first step. We need to get an IP address. Who can give us such an IP address? DHCP, or Dynamic Host Configuration Protocol. That's a part. So your computer sends a DHCP discovery request, and this DHCP discovery request will be sent out of your computer to find the DHCP server in your network. And the DHCP server, usually you have a DHCP server in your Wi-Fi home router. So in any Wi-Fi home router, there is a small DHCP server that gives the IP address to all the devices in your home that connected to your Wi-Fi network. So the DHCP server is going to send the response, and this response is going to send back to your computer, and then your computer will be assigned an IP address, gets an IP address. In addition to IP address, it's going to get a DNS IP, the IP address of the DNS server that you can send your DNS request, because as I said, at the end of the day, any name, any URL should be converted to an IP address, and you should have a DNS server to ask him, okay, what is the IP address of this website? And also you need to have the IP address of the gateway, a point in your network that connects you to the internet, just like a regular gateway in any home or any place. From through a gateway we go in or come out, right? The same thing happen. So we need to have the IP address of the gateway computer in our network. So DHCP provides this information: an IP address, a DNS IP address, and the gateway IP will be given to every computer. In addition to that, as I said, now we are just going to a more extended version of this answer to this question. Okay, so when I get an IP address, my computer or my phone get an IP address now, it is able to communicate. But before going to communicate, he needs to talk to his gateway, the point that connects me to the internet. For doing that, I need to use another protocol that we call it ARP, or Address Resolution Protocol. The Address Resolution Protocol converts an IP address to another address that we call it the MAC address. And this is something we call it at layer 2 in OSI layer. The OSI layer have 7 layers. We at the lower layer, we are talking about physical, MAC, network, and transport, right? So at the MAC layer, layer 2, my phone need to communicate with the gateway through something we call it the MAC address. And to get the MAC address of my gateway, the network gateway, I need to use ARP protocol, or Address Resolution Protocol. Then my computer need to send the ARP query, to the gateway, and gateway sends back the response. Okay, this is the MAC address of the gateway, and then my phone is able to communicate with the gateway directly. So you see, we can go deeper and deeper in the rabbit hole, right? And then we go to the DNS. In the previous versions, which was the simpler version, I just jumped to the DNS. But here I went through more stuff, more protocol. I talked about DHCP, I talked about ARP, right? I can talk about more even stuff. And then, okay, now I'm going to visit a website that is not in my browser cache. And now I have to ask the DNS server, okay, what is the IP address of that website? And here again, it depends on the DNS server. If the website that I'm trying to reach is in the cache, my DNS server cache, okay, I can have the response right away. Otherwise, the DNS server have to go through the name resolution procedure, asking from the root name server, then the top level domain, then authoritative name servers, and get the final response, and then turn it back to my browser, right? So This is the case, and also in the middle, we are going to send our packets through a network of networks, many computers. That these computers also are communicating to each other via different sort of networking protocol. Okay, that they are interconnected to each other and communicating to each other. So you see the response from the DNS, and if whenever, let's say, I have the DNS response, then that's what I start talking about again, HTTP and TCP. So HTTP and TCP was the part that I mentioned earlier, right? About, again, we establish a TCP connection. We are something we call a three-way handshake. So your computer send a SYN, the website is going to send you a SYNAC request, and then after receiving the SYNAC request, then you send an ACK, and then both parties understand, okay, we are going to establish a connection, and through this connection we are going to transfer data, which is HTTP in this case. So the HTTP request will be sent to the target, to the destination website, and let's say google.com, and then the content, the page, whatever you are trying to visit, it will be fetched and sent back to you over the established HTTP connection on top of the TCP connection that has been established. Okay, so this is again, I can say, detailed version of the initial version that I said, but it can be even more details. We can go deeper and deeper with further details. Okay, and there is a very interesting repo in GitHub. The name is What Happens When, and it provides a very detailed explanation what happens really when you want to visit google.com. It has been even translated in Chinese, Japanese, Korean, Spanish. Yeah. And it starts from pressing G. What happens when you press G? When you press G on your keyboard, there is a interrupt or request, IO request will be sent to your CPU, and how your operating system is going to handle that, how it's going to open a socket, network socket, and go beyond this, and many details on the operating system. What happens if you are using Windows? What happens if you are using Mac? What happens if you're using Linux? And then after processing this, says, oh, are you using HSTS? HSTS is a protocol that actually enforce you to use HTTPS, not HTTP, because HTTP is not secure. So your browser makes sure you have a secured communication. So HTTP, strict transport security, or HSTS, enforce your communication to become HTTPS. And if you're using HTTPS, the story is a little bit different, because now you have to connect, let's say, to google.com, and your browser need to extract a public key from the google.com certificate. So the website has a certificate, the green lock you see in your browser in Chrome, and that certificate has a key, we call it public key, and using that public key your browser can encrypt data. But before doing that, okay, it extracts the public key from the certificate. Your browser generates a random number, they call it a session key, and encrypts that session key with the public key of the google.com. So nobody can see what is this randomly generated session key, because it is encrypted by the google.com public key, and then send it to the google.com. So google.com, the website, received that, and it is able to decrypt it because it has the private key of that public key, right? So it decrypts that, and now both your browser and google.com have that generated random session key. Okay, and then using that they can encrypt and decrypt data both way, and then you have a secure connection established between your browser and google.com. Okay, this is again a little bit more details about how this HTTPS connection is going to work here. And we are going to use again HSTS. Mostly the browsers now check if it is available to be used, HTTPS is available or not. And the rest, again, you see here DNS lookup, we see about ARP, we see about all those details that I just mentioned. And it can be even more details. Let's say if somebody says, okay, what happens when my phone associates to Wi-Fi? Wi-Fi is using a standard, we call it 802.11, right? And there are physical multiple versions of this protocol. We have 802.11a, b, g, n, x. Which protocol is going to be used here? Or we have an algorithm, we call it CSMA CA. how the CSMACA guarantees that I can associate to a Wi-Fi access point. Or at the MAC layer of that, we have something we call a DCF, or distributed coordination function. Okay, how this DCF guarantees that multiple users at the same time communicate to an access point when the nature of the Wi-Fi protocol is half duplex, means not two person or two device can send or receive at the same time. It should be, some time sharing or frequency sharing, some mechanism. So you can see we can have different versions again. And so when you're going to present the answer, know your audience and what is their background and what they are willing to know. Very basics or more advanced version of that. Which part is more interesting to them? Application part, something on the networking side, something on the physical layer. Depends on that. And many people that have been in IT field maybe for many years, still they have no idea that how this process happens, because they stick to the routine for a long time, and especially for young engineers, I strongly suggest, if you're going to learn something, try to start from the basics 101 and have a good understanding about these foundations, and it definitely helps you to have a better troubleshooting skill. And in hard cases, complicated scenarios, you are able to deal with those situations better and better if you have a better understanding about those basics and fundamental. I hope it's going to be useful for you guys, and wish you all the best.